This is video 4.18 where I'll explain figure 4.8 in the text on page 186. Now, before we actually get to this figure, we're going to go back to table 4.8 on page 182. Now, the scaled coefficients that we have here in the PCA summary table, they can be used to create a vector plot of three variables within the principal component space, which is going to be here. Now the values in the matrix, or in that table, they're coordinates of the three variables with regard to the two orthogonal axes, axis 1 and axis 2. Or you can just say component 1 and component 2. Now let's take the values that we had in the table for for the verbal vector. The scaled coefficients, we had 0.868 and 1.802. So the vector for this, we can go this way, 0.868, and then we'll go up 1.802. to plot the verbal vector. Sorry if it's not completely straight, but as long as I do this, you know it is a right triangle. And then we can move on to the math test. We had 3.823, so we go 3.823, and then negative 1.176, so we can go down 1.176, 3.823. Now maybe that's not completely accurate, but I think you get the gist. Maybe it's over this way a little bit more, I'm not sure. And then last one for the logic test vector, we go 4.691, so all the way down to about here, 4.691, and then we're going to go up 0.625. And of course these are all right triangles. Now if you wanted to know the length of these three vectors, they can be calculated using the Pythagorean theorem. So let's take, for example, this last one that we did. If we do 4.691 squared plus 0.625 squared, we do in fact, if my calculations are correct, get 4.73 squared. So the length of this one would be 4.73. If we do the same thing for math and verbal, the math comes out to be 4, and then the verbal comes out to be 2. You may notice that 2, 4, and 4.73 are in fact the standard deviations for each of the three variables. And we can calculate that another way. If we go back to table 4.8, we know that the squared coefficients summed were 4, 16, and 22.4, which were the diagonals on a covariance matrix. Well, the diagonals on a covariance matrix are in fact the variance, and we know that the definition of standard deviation is just the square root of the variance. So the standard deviation of each variable is the length or the magnitude of the vector representing that variable. So that's just a simple explanation of how we got figure 4.8, the vector plot from the scaled coefficients of the three mental test variables, verbal, math, and logic, from a principal components analysis. Hope that was helpful. Have a good day.